Hello and welcome to the Syngenta piece in the Syngenta PGR Roadshow. I've got sort of four main topics I want to talk about, starting with the sustainability site project at Elveden. And we've got some nice kind of data, some visual differences to share there. And also we did some application work, which is really interesting, and some biostimulant and endophyte work that I'll also go on to talk about. And then we'll finish up talking about the fungicide data, the fungicide trials work we did this year, to sharing that data and making recommendations for 2024. So the Elveden project, the sustainability project Elveden, the field looks like this. It's a 17 hectare field, so the three sections are about 5 hectares each. And on one side, we've got the sort of regen. So the ethos behind this is min-till, building soil fertility, so that kind of low input, that sort of system. On the other side, we've got the conventional system, which is basically kind of based around profit, growing the most profitable crop. And then in the middle, we've got this IPM plus. So this is kind of between the two. So in this situation, in the beans, it had a cover crop established in the autumn, and then it was sown into spring beans along with the regen area in the spring. So with the spring we sowed the spring beans sort of at the end of March, the 28th of March. So both areas of both the regen and IPM were spring beans. The conventional area was winter beans. And then over and above that, this is the second year of the project, sorry. The first year was winter barley. And in the second year, we decided to establish a living mulch. So half of the regen area is covered in a living mulch. And then if you look as the trial goes across the way, or sorry, if you look at the strips across the way, that is our fungicide and biological product trial. And over above it, there's another area, which is the application work. So I'm going to go through these different areas of the field and talk about the trials. So we focus first on the small plot trials. I'll just pull out one visual interesting difference here. In the background is the regen living mulch area, and then we have the regen area without the living mulch. So this was established at exactly the same time. This area had no fungicide at all, and so early to mid-June we saw very little disease. We decided no fungicide needed. We did a spray on the IPM area, even though there wasn't a lot of disease. We thought we'd use a low rate of or a single application of Amistar. So we did half a litre of Amistar on the IPM area, and you could see here visually how the rust came into the crop as we moved into July and just totally took the leaf off, really. So the green in the background is the living mulch, and this area is just basically beans covered in rust. So quite an interesting difference. So the half a litre of Amistar was sprayed on the 16th of June, and then the trials, which look a bit greener, were sprayed a slightly later. So there's also an interesting difference there with timing. That slightly later timing created a bit of a difference. And then, of course, we've got different treatments in the trial, which add a further difference. And I'll go on to talk about some of this as we go through. Firstly, though, I want to concentrate on the application trial. So we looked at three things in the application trial. The first thing was the water volume, and we found that between 100 litres and 200 litres, the plots we harvested, or the sections of the plots we harvested, so we sprayed the entire plot and then harvested the middle to get a fair comparison for yields. So the middle of each plot, that is. And we found that water volume wise in this crop, we didn't see any difference between 100 and 200 litres. Now, to be fair, the crop we had at Elveden was sown end of March. It wasn't maybe as tall as we get in another season, so it was kind of middle of thigh height, that sort of height. So you can appreciate that in a bigger crop, you could justify that higher water rate that could well be justified. And sorry, down the side is tons per hectare. So these are yield results, and we saw very little difference. The second thing we looked at was angled nozzles versus a vertical nozzle. Again, in both situations, a 90% drift reduction nozzle. So we started with Leckler ID3. So that's a vertical nozzle. This is at the 100 litres of water rate, compared to our new 3D90 drift reduction nozzle. So both 90% drift reduction. And you could see we had a step up in yield moving towards the angled nozzle at both water rates. So again, tons per hectare down the side, and you can see a nice pattern that both water rates showed this improvement in yield from using the angled nozzle. So better penetration in the crop and more even coverage and deposition on the crop. And then the third thing we looked at was comparing our new 3D90 nozzle, so that our new 90% drift reduction nozzle, to the old angled 3D90 nozzle, the old angled 3D nozzle. So this was a kind of old standard. The 3D doesn't have very much drift reduction, and it has to be used at a low water volume. So it kind of produces a bit of a misty spray, but was a standard at one time. And you can see again, in both situations, the new 3D 90% drift reduction nozzle is delivering better yield over both water rates. So nice little interesting trial, and it hopefully backs up our advice that the new 3D90 is a very effective nozzle and will give good control of disease and good efficacy in the crop. So I'm going to move on now, just to talk about some of the differences in the three sections across the trial, across the field. First, we're going to look at the regen area, and this kind of highlights some of the complications that you have when you're changing systems. So we can see on in the middle of the field where the cursor is, this is the area that had the living mulch. The area next door is the regen area without the living mulch. So this had a cover crop. It was sprayed off with a good rate of glyphosate, and we used a drill to drill direct through the trash, and you can see very clean. With the living mulch, because we had a living mulch established, which was a kind of low growing, or it's a mix of low growing clovers, we used a lower rate of glyphosate, and we've ended up with a real competitive weed situation at the top here. So you can see the rows of beans until we get in the weeds, and then you can see the weeds competing with the rows of beans. And some of this is because of the lower rate, I'm sure, but also potentially a bit of shading from the beans. So we had to come back and sort this out with an additional herbicide at another day. And then I thought I'd show a drone scan of the whole field. So you can see the living mulch area here, and then the regen area without living mulch, the IPM area in the middle. So you can see again this nice effect of that ½ litre of Amistar compared to no fungicide. And then we've got the conventional. So this is the winter beans. These were sown end of October, and they're starting to senesce here. And then you also notice the really nice plots across the field. So a really nice picture. Just draw your attention to a couple of areas in the field. The winter beans, if you remember back in autumn 2022, we had a bit of frost, and we had quite a bit of frost damage in the winter beans. And this area here was worse affected. It's quite high pH. I suspect there's an issue with phosphate availability. So growth was not so good here. We also, the crop looked so poor, we also didn't spray any herbicide, and we had some flicksweed turn up in here. So we did get a bit of competition with weed at the top end of the field. So it's a real, I don't know, maybe in hindsight, the winter beans weren't the best selection for this field. But it was a good comparison in the project. And then on the far side, you can see the weed that we had in the living mulch area, and you can see this kind of higher pH area spreads across the field in this manner. And also, just to point out the it's a chalk subsoil, and you can see the fissures in the chalk. So during the dry weather, you could see this affecting the crop by looking above from the drone. So I point this out because I'm going to show you what the yields look like as we move on, and then talk about the comparison of different systems from a cost point of view and a return point of view. So here's the yield map, and you can see straight away we've got this nice green area in the middle. So this is the IPM plus area, possibly better soil through the middle of the field, further up into the top of the field. You can see this high pH area, but once we get down here, we've got some good crop and good yields. And then again at this far side, the weed, and then also this possible effect from soil type as well. So you can see when we think about the yield of the 3 different areas, the IPM looks really good. So no surprise that yielded well. The regen area, you can see less good. And then also interestingly, the living mulch area, if you cast your mind back, we had a really dry June. The crop started to wilt a bit. And I think it was worse where we had the living mulch, just competition for moisture from the living mulch in the crop. And also interestingly, we saw less rust, or the rust was later coming into this, and I think it's because the crop wasn't growing quite so well. So the rust wasn't doing quite so well establishing onto the living mulch area. Okay, so let's just look at the costs for each of the systems and the returns. Just to kind of explain how these figures are laid out. All these figures are in comparison to the conventional system. So this line represents the cost of the conventional system. Anything above that line is more expensive, and anything below the line is a saving. So if we look at the costs for cultivations, for instance, on the conventional system, on the IPM system, we had the cost of incorporating the cover crop. So we looked at it as though it was a kind of conventional grower. So we had to chop up and incorporate the cover crop. We also, because we didn't invert the soil, we used a low disturbance subsoiler on both the regen and the IPM system. So that's where this additional cost comes from. The low disturbance subsoiler worked out similar to plough and press, which is what we used for the conventional system. Both of these systems had a cover crop, so we had to manage the cover crop. And as I said, we used a lower rate on the living mulch area to look after the living mulch. Herbicide wise, we had a bigger saving on the IPM and the regen area without living mulch, because we spent a bit of money controlling that cranes bill. So still lower cost than the conventional winter beans, because we had a spring established crop. And in the winter beans, we had to chase after the grass weeds that emerged. And then fungicide-wise, we didn't put anything at all on the regen area, fungicide-wise, and the IPM had that ½ litre of Amistar. So a saving on the 3-spray system on the conventional beans. Insecticide-wise, no insecticides at all on the regen, and we did with it being spring beans, we did a spray for pea and bean weevil on the spring beans, which we didn't do on the winter beans, although we did spray for black bean aphid on both the winter beans and the IPM system. And then foliar feeds were the same. So we go across and see what that looks like as returns. So as I said, the IPM system, the yield and the return was good. It was kind of arguably in the best part of the field. The regen area without living mulch showed a lower yield, no fungicide, so more green leaf and longer yield building. And then the regen area with the living mulch, I think the competition of the living mulch potentially reduced the yield, so performed under the conventional crop. But On the plus side, we have stewardship earnings. So on the conventional, we didn't have any stewardship earnings at all. So the cover crop gave us a return for establishing cover crop over winter on the IPM. The regen, we have a share of the pollinator strip in the field as well. And of course, no insecticide use. And then if we look at the living mulch, we've got a payment for the living mulch in the living mulch area as well. So the stewardship payments build up as we go across the systems. And then we look at the kind of the total return. So you can see that the IPM returned £50-ish more than the conventional. Despite the lower yield, when we look at the stewardship earnings, the regen area without the living mulch returned similar, so 43. And then I think because the yield was such a penalty, etc., the area of the living mulch unfortunately returned less than the conventional system. So we've got some nice data there. Apologies, there's a couple of bills that I've forgotten about. But I think the most important thing that comes from this project really is that it's a long-term project. It's not a one-year shot project. And anybody who's done this kind of movement towards regen, I think will say that it takes a couple of years for the soil and the system to get bedded in, for the soils to get used to the improvement in microbial, etc., and possibly building that structure in the soil. So interesting results, and hopefully it shows how the different results can change the way your return is built. But I think it needs to be a longer term look at it. So this project goes on for a few years yet, and hopefully we'll build on it and build on the data. Okay, so the last thing, the next thing I was going to cover really is to look at the fungicide and biological trials. And this was this area here. So you can see from the treatment list, we had untreated area to this side. Then we had Elaticera, so a nice green strip. Then we had Amistar at a litre, so slightly higher rate than the field rate, to be fair. We had Signum at half a kilo. And then we had Elaticera with biologicals as the last part of the trial. And if we focus in on the very last section, so this section over here, you can hopefully see that we've got a difference between the last two plots. So this plot's a lot greener than this plot. And this is what I want to talk about because I think this is of exciting interest, really. So this is where we used Vixeran in with the Elaticera compared to another biostimulant yield on. So what is Vixeran? To talk about this new product, and I've got about 5 slides just to cover the data and the detail. So Vixeran is a azotobacter. It's our product is in a sachet. It's quite a low rate, and we recommend kind of timing that early flowering. It's good compatibility with CP products, so you can hopefully put it in when you're doing early trace elements, that sort of situation. And how does it work, or why is it something that we're so interested in? Well, it takes atmospheric nitrogen and it fixes it in the plant or in around the roots to make ammonium. So on a crop where we're not using nitrogen, I think this is an interesting concept, and we've certainly seen some good results in our trials. And what sets our product apart from other products is this ability to be in the plant, so it goes in through the stomata, but also to live around the root and fix nitrogen around the root. So why is this such an interesting point? Well, I think we all know that beans, we can't put artificial fertilizer on beans, and we rely on the nitrogen from the soil and also nitrogen from fixation from the rhizobium that form on the roots. These form quite quickly after the plant's established, but over time, and as the plant starts to fill its beans, the plant gives up on the rhizobium. It puts the carbohydrates into bean filling, and the rhizobium start to senesce. The rhizobium start to senesce. So this is a kind of an alternative supply of nitrogen for the plant. The other thing, of course, is with bean weevil, the larvae eat the nodules. So if you've got a real burden of pea and bean weevil, you can't be too sure of how much nitrogen you're getting from these nitrogen fixing nodules. So it's an interesting concept to provide an additional nitrogen source to the plant over and above what's in the soil and potentially from the nodules. So we did a few trials this year, and it's just a summary results. I'm not going to spend a lot of time talking about this, but in all our trials, so whether they were the unreplicated plot trials at Elveden or in our replicated trials, we saw a positive effect on yield. I'm not going to promise you half a ton on every crop, but it looked really interesting, and it was really pleasing to see a product that delivered a result in every situation, which was really good. And I think, you know, potentially part of that is we're not putting any nitrogen, we're not substituting nitrogen, so it's an interesting concept, exciting product. So that's all I was going to say about Vixeran. So nice and brief. If you want more details, please look on our website. You'll find a good lot of data there, and we'll be doing more work on legumes through this year. We've got work with PGRO. So just to finish, I thought I'd talk a little bit about the season and about our fungicide portfolio and our recommendations. So if we cast our mind back to May and June, we saw plenty of chocolate spot building through crops in April, and everybody, you know, the weather was pretty bad and everybody was concerned about the amount of chocolate spot we were getting. This certainly built through May and started appearing up on the canopy. And then, of course, when we moved into June, conditions dried up. We got hot and dry, low humidity, and it kind of put a bit of a dampener. It wasn't ideal conditions for chocolate spot, and you could see we got a growth, nice clean growth coming after that kind of mid-May time. So it's an interesting season. A lot of kind of worry at the start, and then as the season went on, things got a little bit too dry, to be fair. So just wanted to share some of the data from PGRO trial this year. We had a 3-spray trial planned. So half of the trial didn't get any early spray. So this is in winter beans at Southery. And the first application was put on the 18th of May. So as I said, half the trial didn't get any spray at all, so untreated. The other half got Amistar at 0.75 of a litre, plus some of the treatments got biological as well. And you can see from the results, we had a positive effect on chocolate spots. So this is in the middle of the canopy, so kind of that infection was already there by the time we sprayed this. So it's about keeping the middle and the top of the canopy clean. But you can see we had a good positive effect on chocolate spot, and that would allow you to. This is quite an early spray that would allow you to save product for that traditional T1 timing when we start to see pods appearing. We also had a good effect on downy mildew from the same spray, so exactly the same scenario. If we look at the middle of the canopy and the top of the canopy at the beginning of June from that 18th of May application, you could see a significant difference between the level of downy mildew, so good control. And then just to move on to rust, so when that hot weather came, the year turned into a rust season, and rust developed pretty quickly through July, and that was true of the Elveden pitches as well. You can see that by this stage, so when this was assessed on the 17th of July, we'd applied all 3 treatments. But what you can see is clear is where we've got Alatus, no surprise, we've got really good control of rust, very, very low levels, where we're around about 70% in the untreated. So as you'd expect, Alatus era showing really strong rust control. So just a quick summary of our classic timings. For that early spray, so that was the middle of May spray in the trial. So you can see the timing varies slightly according to the crop. If disease is building like it did last year, an early Amistar will hold your disease until you get to the classic T1 timing, so that first pod timing. And then Alatus era has shown, as you can see from the trials, good control of rust and disease from that first pod. And then, of course, the disease persists and conditions persist. A second spray is usual in winter beans and sometimes needed in spring beans. So that's when we recommend a T2, and our recommendation is Amistar, sort of 21 to 28 days after the T1. So not much changed, but just to refresh the message. Just wanted to say also, quick reminder, Elasticera is also on combining peas. So it's on other crops apart from field beans. And I think we showed this last year. So really good data, good disease control. So you can see powdery mildew, 50% in the untreated from that early flower timing. So we'd recommend this as the ideal timing in peas. So this is combining peas. And you can see Elatus performing really well, giving robust disease control from that early timing, one single spray, even compared to a 2-spray program. So a really good choice for disease control. Okay, so that's me wrapping up. Thank you very much for your attention, and hope that was useful.